Good morning, class. Today, we're going to learn about something very interesting called a monitor in programming. But it's not the kind of monitor you use for your computer. It's a special tool that helps us share things without any problems. Are you ready to learn?
Yes, teacher.
First, let's talk about what a monitor is. A monitor is a programming language construct that helps us control access to shared data, much like traffic lights control the flow of cars on a busy road. It's like a special rule book that makes sure everyone takes turns and no one fights over shared resources. Now, let's start with a fun example. Imagine we have a box of toys that you all want to play with. Let's call it our sharing box. Now, if everyone tries to grab toys from the box at the same time, it could get chaotic, right? That's where our sharing box's characteristics come in, just like a monitor in programming. These rules help everyone take turns and keep things orderly. To understand how monitors work, let's go through their main characteristics using our toy box example. We'll start with the first characteristic. Characteristic number 1. The local data variables are accessible only by the monitor's procedures and not by any external procedure. This means only the special rules or procedures we set up for a sharing box can access the toys inside. Think of the toys inside the box as the local data. Only you can access these toys, not anyone outside. So, you can't just reach in and grab a toy without following the rules. Stop! Alex, you can't take a toy directly. You need to follow the sharing box procedures. This keeps everything organized and fair. Characteristic 2. A process enters the monitor by invoking one of its procedures. This means you have to follow a specific method or procedure to use the sharing box. Sarah, if you want to take a toy, you have to ask first. That's like invoking a procedure. Let's call our procedure Ask for a Toy. Great! Sarah just entered the monitor by invoking the Ask for a Toy procedure. The last characteristic is only one process may be executing in the monitor at a time. Any other processes that have invoked the monitor are blocked, waiting for the monitor to become available. Later, when the condition is satisfied and the monitor is again available, the process needs to be resumed and allowed to re-enter the monitor. In programming, this means only one thread can access the shared resource at a time. This ensures that only one person can use the sharing box at a time, preventing chaos.
Hurry up, Sarah.
Okay, I choose the car. See how Sarah is taking a toy while Alex waits? He have to wait his turn because only one person can use the box at a time. This is called mutual exclusion. Alex is waiting because the monitor, our sharing box, is already being used by Sarah. Once Sarah is done, the next person can go. A monitor supports synchronization by using condition variables. These are special data types inside the monitor that help manage the conditions under which a process can continue or must wait. Condition variables are a special data type in monitors, which are operated on by two functions, which is cWait and cSignal. cWait suspend execution of the calling process on condition C, while signal resume execution of some process blocked after a cWait on the same condition.
If I want to put a toy in the box but it's already full, I use cWait to wait. Now, the box is free for someone else to use.
If I take out a toy, making the box empty, I then uses cSignal to signal that the box is now empty, and someone can add a toy.
I hear the signal and puts my toy into the box. This process ensures that everyone takes turns and no one gets blocked indefinitely.
Okay class, now I'm gonna explain and show how monitor structure looks like. This is structure of monitor. We have all procedure that consider as critical section and put it in one place as monitor procedures. New process will queue to use the monitor based on condition. We'll pass to which condition to be used. We have C wait for each condition and C signal to bring back the process to monitor. So, to summarize, monitors are great because first, they are easier to implement. Second, they provide automatic mutual exclusion. Third, they help overcome timing errors. And lastly, shared variables are global to all processes within the monitor. These advantages make monitors a powerful tool for managing shared resources in programming. They keep everything simple, organized, and efficient.